Hello, I am Prasad sir from Prasad's for Learning and Perfection. Today we are going to prove the theorems of the circle chapter. Let's begin with the first one. I have already written the theorem. Theorem number 1. Prove that measure of the inscribed angle is half the measure of the intercepted arc. Here a condition is given. Center of the circle lies on the side of the angle. When a theorem is asked to prove, first to draw the diagram. So I am drawing the diagram. Circle with center O. This is angle ABC inscribed in arc ABC. ABC is the inscribed angle inscribed in arc ABC, and AC is the intercepted arc. If you see here, I am satisfying the condition center of the circle lies on the side of the angle. Center lies on the side of the angle. So I have drawn the diagram. I am writing the given. O is the center of the circle. Angle ABC is inscribed in arc ABC. Arc AC is the intercepted arc. What to prove? To prove that measure of the inscribed angle is half the measure of the intercepted arc. Measure angle ABC is half of measure arc AC. If arc AC is 60 degree, measure angle ABC will be 30 degree. That's the idea. So this thing we have to prove it. There's a small construction you have to do over here. Join radius OC. Construction. Join radius OC. I have drawn the diagram. I have written the given, what to prove, and construction. Before I start proving it, I'll give an idea how to prove it, how to go about with it. We have to use three basic ideas over here. Number 1, isosceles triangle theorem. Number 2, remote interior angles theorem. And number 3, measure of the central angle is the measure of the corresponding minor arc. I'll give an idea about it before we proceed. I take the triangle OBC. This triangle. First I'll explain in short and then we'll go for writing. This is triangle OBC. In this triangle, OB is equal to OC, radii of the same circle. Therefore, angle OBC is equal to angle OCB by isosceles triangle theorem. Next one. This is triangle OBC. Angle A angle AOC is the exterior angle for triangle OBC. Angle AOC is the exterior angle for triangle OBC. By remote interior angles theorem, angle AOC is equal to angle OBC plus angle OCB. Remote interior angles theorem. I'll write down these steps. Proof I'll begin. First, referring this triangle. In triangle OBC, OB is equal to OC, radii of same circle. Second, therefore angle OBC is equal to angle OCB, isosceles triangle theorem. Referring this figure, I have written these two steps. Now referring this figure, third step, angle AOC is the exterior angle of triangle OBC. Therefore, angle AOC is equal to angle OBC plus angle OCB, that is by remote interior angles theorem. Referring this figure, these two steps. Now if you see, angle OBC and angle OCB are equal. So for this angle OCB, I can write angle OBC by the second step. Therefore, angle AOC is equal to angle OBC plus angle OBC by second step and fourth step. I've used the second step and substituted in the fourth step. Therefore, angle AOC is twice of angle OBC. Angle OBC plus angle OBC will become twice of angle OBC. Seventh step, for this angle OBC, I will change the name and write for this angle OBC, I'll change the name and write angle ABC. It's the same angle with a different name, angle ABC. For this 2 I got it down, 2 I got it down, so half of angle AOC. 2 I got it down, so half angle AOC is equal to angle ABC. For angle OBC, change of name. Now we come to the last circle. If you look at this angle AOC, it is the central angle. Measure of the central angle is equal to the measure of the corresponding minor arc. So, 8th step, measure angle AOC is equal to measure arc AC. Measure of central angle is equal to measure of corresponding minor arc. Measure of corresponding minor arc. Looking at the 7th and the 8th step, angle ABC is equal to half. For angle AOC, I made a substitution ready, that is measure arc AC. So I have proved that measure of the inscribed angle ABC is half the measure of the intercepted arc using the three basic things. Isosceles triangle theorem for the first two steps. Remote interior angles theorem for the next two steps. Then I substituted it for angle OCB, I substituted angle OBC. So angle AOC will become twice of angle OBC. Then 2 I got it down. So half angle AOC. And for angle OBC, I changed the name and I wrote angle ABC. It's the same angle. And the last basic idea, measure of the central angle is equal to the measure of corresponding minor arc. So for angle AOC, I wrote measure arc AC. So measure angle ABC is equal to half the measure of arc AC. This is the very first theorem, inscribed angle theorem. Now we'll start with the second theorem. That is tangent segment theorem. What's the statement that will be given? Prove that tangent segments drawn from an external point to the circle are congruent. So first thing, as I've told you, we'll draw the diagram. Circle with center P. From an external point A, tangent segments are drawn to the circle. I'll call them as AB and AC. I will prove that AB is equal to AC. Tangent segments drawn from an external point to the circle are congruent. AB equal to AC. Given. After the diagram, next step is given. Circle with center P. AB and AC are tangent segments to the circle from an external point A. From an external point A. What to prove? That these tangent segments are congruent or equal. That is, AB is equal to AC. Diagram given. What to prove? Next thing is the construction. I will join PB, PC and PA. Join PB, PC and PA. Very, very simple theorem to prove, can be asked for 3 marks. I will take the triangle PBA and triangle PCB. 2 triangles. I'll prove them congruent. Once I prove these 2 triangles congruent, that's very simple. I can say therefore AB is equal to AC, corresponding sides of congruent triangles. So my first aim will be to prove triangle PBA is congruent to triangle PCA. Look how I'll prove it. PB is equal to PC, radii of the same circle. PA is equal to PA, common side. This side is common for both the triangles. angle PBA is congruent to angle PCA. Why they are congruent? Tangent theorem, each 90 degree by tangent theorem. So I've got three things now to say the two triangles are congruent. If you can see, both the triangles are right angled triangles. Hypotenuse is congruent and the side is congruent, PB and PC. So the two triangles can be said congruent by hypotenuse side test. And when we say the two triangles are congruent, we can say that AB is equal to AC, corresponding sides of congruent triangles. In short form, we write CSCT. Let's write it down. Proof. First one, in triangle PBA and triangle PCA. Anything you can write first. There's no hard and fast rule what to write first. Anything. Angle PBA equal to angle PCA equal to 90 degree by tangent theorem. PB is equal to PC, radii of same circle. PA is equal to PA, common side. Therefore, triangle. Now, when you name the triangle, if I name it this triangle PBA, triangle PBA congruent to. Now name the other triangle as per one-to-one correspondence. If you are named this as PBA triangle, this has to be named as PCA. You are going from this side and then here PBA. From this side right angle and here. So this side right angle and here PCA. If you would have named this triangle as PAB, from this side you have taken it there, then this triangle you have to name it as PAC. You cannot name it as PCA. If you are named this as triangle PAB, this has to be named as PAC, not PCA. But as we have named this as triangle PBA, this as per one-to-one correspondence, as per the marking, if you see, triangle PCA by hypotenuse side test. Therefore, two triangles are congruent. Therefore, AB is equal to AC, corresponding sides of congruent triangles. If the two triangles are congruent, the remaining parts are also congruent. They are the corresponding parts of those congruent triangles. As these are the sides, we specifically write CSCT, which means corresponding sides of congruent triangles. So very, very simple theorem to prove. Just say the two triangles are congruent by hypotenuse side test and then write AB equal to AC, corresponding sides of congruent triangles. That ends the second theorem proving. Now we'll start with the third theorem. That's theorem of cyclic quadrilateral. The question asked will be, prove that opposite angles of a cyclic quadrilateral are supplementary. Again, the first thing, diagram, circle. I need not make the center. I will make a cyclic quadrilateral. I'll name it as ABCD. Second step, given quadrilateral ABCD is cyclic. What to prove? Prove that opposite angles are supplementary. Angle A plus angle C equal to 180 degree. Opposite angles are supplementary. What do you mean by supplementary? If the sum of two angles is 180 degree, they are called as supplementary angles. So angle A plus angle C. Why did I take A and C? Because the theorem says so. Opposite angles are supplementary. So angle A plus angle C is 180 degree. As well, angle B plus angle D is also 180 degree. No construction over here. The basic things to be used over here is inscribed angle theorem. The theorem number 1, what we proved, we will be using it over here. If you look at this diagram, this is a part of this figure only. Angle BAD is inscribed in arc BAD and arc BCD is the intercepted arc. So my first point of the proof, referring this figure, angle BAD is inscribed in arc BAD and arc BCD is the intercepted arc. So using inscribed angle theorem, angle BAD is half of measure arc BCD. That is by inscribed angle theorem. Now look at this figure. Same diagram I have taken this figure from here. I will take the angle BCD is inscribed in arc BCD and arc BAD is its intercepted arc. So referring this figure, third point, angle BCD is inscribed in arc BCD and arc BAD is the intercepted arc. So fourth, here we will use again inscribed angle theorem. Angle BCD is half of measure arc BAD. That is by inscribed angle theorem. Referring this figure, inscribed angle theorem. Referring this figure, inscribed angle theorem. Now I'll add step number 2 and step number 4. That will make my step number 5. Angle BAD plus angle BCD is half measure arc BCD plus half measure arc BAD. Equation 2 plus equation 4. I have added these. Sixth step. Angle BAD plus angle BCD. Here I take out half common. When I take out half common, measure arc BCD plus measure arc BAD. Half is common. In this step, just I've taken out half common. Now, if you look at measure arc BCD, measure arc BAD in the main figure or any figure, measure arc BCD here, measure arc BAD here, that makes a complete circle, and measure of the circle is 360 degree. So I can write measure arc, I'll write but measure arc BCD plus measure arc BAD equal to 360 degree. Measure of a circle. Measure of a circle. Because if you add these two arcs, it becomes a complete circle whose measure is 360. So for measure arc BCD plus measure arc BAD, I will substitute 360 degree. And here I'll just write now angle A instead of angle BAD, I can write angle A. Instead of angle BCD, I can write just angle C. Half, and what is measure arc BCD plus measure arc BAD from the 7th step? 360 degree. And when you cancel it, this will come to 180, 9th step. Therefore, angle A plus angle C equal to 180 degree as per the requirement. I proved that the opposite angles of a cyclic quadrilateral are supplementary. That means their sum is 180. Second pair also to prove. Angle B plus angle D equal to 180. But that is not required. Just we'll write similarly angle B plus angle D equal to 180. So that's very simple. We have just made use of inscribed angle theorem. Angle BAD is half of measure arc BCD. Inscribed angle theorem. Angle BCD is half of measure arc BAD. Then I added the two. In this step, I just took out half common. Next step, measure arc BCD plus measure arc BAD, that makes a complete circle. That's of 360 degree. So the next step, for this measure arc BCD plus measure arc BAD, I substituted 360 degree, cancelled. So measure angle A plus measure angle C is 180 degree. And similarly, we can say that measure angle B plus measure angle D is 180. That is theorem of cyclic quadrilateral. So today we have proved 3 theorems. That's the end of today's video. So again, I would like to tell, I am from Prasad's for Learning and Perfection. We are having classes for 8th, 9th and 10th, SSC and ICSE board and all the subjects. Thank you very much and wait for my next video.